Okay, so a hot air balloon is flying at an altitude of 1,236. It descends at a rate of 10 meters per minute. Okay. Without graphing, what are the intercepts? What do they represent? So your y-intercept, that's going to be your altitude. Your y-intercept is 1,236 meters. It represents the starting altitude of the balloon. Okay, so it's your starting altitude. That's where the graph starts. The balloon's high in the air. What you're going to find today is a lot of your graphs are reverse type graphs, in the sense that they start with a full glass of water and then it empties, or they start with the glass full of water. So this is your y-intercept here, and you can find your rise, and then this is your x-intercept. It's your finishing values. It's your run. Okay, so often you're going to see that. So you can, if you have your intercepts, it's easy. If you have a graph where you don't have your intercepts, what you do then, maybe you have one of them, but not the other, you have to find points on the line, right on the grid lines, so you can find your rise and run easily. You got to be careful though, because today we might be going up, right? Your squares here might be going up by 800, which means that each square represents 400. Okay, and your x's maybe are going up by, well, maybe they have a 40 here for your x's, so each square represents 20. So you gotta read your scales. Don't just do this blindly. Okay? Read your scales. Okay. So here we go. Now for your x-intercept, you're going to take 1,236 meters divided by 10 meters per minute, and that equals 123.6 minutes. Your meters cancel. You're not going to do this too often, so don't be concerned about what I just did. I divided my altitude by my rate of change to figure out how long it takes to land. So my x-intercept is going to be 123.6 minutes. That is the time of descent, or time to descend. Okay. Now the balloon has landed. So the balloon starts in the air and it goes down and lands. X is your time. What is the rate of change? It says it begins to descend at a rate of 10 meters per minute. What's the rate of change? Is it a positive number? No. Negative 10. This is all from yesterday, folks. 10 meters per minute. What does that mean? The balloon is descending 10 meters each minute. Okay. Now we have to figure out our dependent and independent variables, so we're going to focus on our depends on sentence. So you need to make a depends on sentence using altitude, because that's one thing we're measuring, and time, which goes where. So say to yourself in your head, blank depends on blank. Fill in the blanks, see if it makes sense. Kyla, what's the depends on sentence? Yeah, altitude depends on time. So your independent variable is time. Almost all the time is time independent. In fact, you can pretty much, for all the graphs you're going to do, you can say time is always independent. Okay, so I can say always time is independent. The dependent variable, this is the one that you measure. Okay, we use a watch, but the watch measures the time. We have to measure the altitude. Okay. So what we're going to do then is graph this. Now use your intercepts to graph. Here's your height. Use your y-intercept. And this is going to be time. Use your x-intercept. Now first of all, we got to figure out, we know that for y, we have 12, 3, 6 is our maximum number. Okay, so we have to divide that by how many squares we have. So please count the squares. How many squares do we have? No, going up, just for a scale. Linear, 9. Okay, so divide that by 9. 1, 2, 3, 6 divided by 9. 137. So what should we go for each square? Each square should represent what? I mean, it's more than 137. What would be a good number to graph? 140? Okay, it's not bad. What's easier though? 150, right? So we don't have to label each square. We can label each other square. So 300, 600, 900, 1200, going up. Each square goes up by 150. Okay, each line. Now we're going to do the same for time. For time, we have a maximum of 123.6 minutes. How many squares or how many lines? 9 increments again. So do your division. So 13.7. So what should we go up by? 15. 15 should work nice. Again, don't have to mark each square. 30, 60, 90, 120. Okay. So what we're going to do now is label our intercepts. Approximately, we don't have to be exact here on the graph. So 1, 2, 3, 6. This one here would be 1350. So 1, 2, 3, 6 is probably about here. Right? Right in the middle is what? 1275 is in the middle. So we're below that. Okay. Do the same for the x now. Approximately where should the x be? Well, 123.6 is going to be just a little bit after 120. Okay. Now you can use a straight line. There you go. So we didn't need to do an XY table, not for this one. We just need to find our intercepts. Intercepts are really important for graphing. We're going to do a lot of that next unit. Okay? So find your intercepts, graph your line. Good. Now, use that to state the domain and the range. Okay? So for your domain, do inequality and interval notation. Remember, it's low and high. Okay? So for your domain, what's the low value for x? 0. What's the high value? 123.6. We calculated that. So x is in between that. Look how easy that was. Okay, change that to an interval now. So low is 0, comma, 123.6. Should we use rounded brackets or square brackets? Square brackets. So we have square brackets. There you go. Okay, you do that for the range now. It's going to be very, very similar. Go ahead for the range. Okay, so for y, the low value is 0, and y is in between 0 and 1, 2, 3, 6. For the interval notation, you use square brackets, same numbers. Okay. Now, if that was discrete data, if those are just graph points, then we just list the values. But it's not. They're specific values, a start and a finish, and they're continuous. Okay, so let's write this in y equals mx plus b first. What's the slope and what's the y-intercept? You've already found that up above. What's the slope, Harj? No. Rate of change is your slope, right? -10. Okay. So it's going to be -10x. And what's b? Austin? What's your y-intercept? That's the b. You found it up here. Y-intercept. Yeah. So plus 1, 2, 3, 6. It's that easy, folks. You already have all the numbers. Now to change it to a function, what letter can we use to represent altitude instead of y? A. Good. What letter can we use to represent time instead of x? T. Wow, not too hard. The -10t plus 1, 2, 3, 6. It's that easy, right? Just do some descriptive letter changes. Okay, go ahead now. This was just on the quiz. We went over it this morning. T equals 45. Find the altitude. So find A at 45. Seven what? 786. Can't hear you. 786? 786. Okay, there we go. Any questions? Good. Pretty straightforward. I want to make sure it's not negative. Next one. Okay, so Caleb has a cell phone plan. There's a monthly fee. This monthly fee, that's your constant. That's what we talked a lot about last year in grade 9. Your constant is your y-intercept. Okay, it's your starting value. Then it's 15 cents for each text message. Okay. So let's change this into y equals mx plus b. What's your slope? What's your rate of change? For each text, what is the cost? Right? 15 cents. So 0.15x. How much do you have to pay if you don't make any extra texts? 20 bucks. Okay. So let's change it to function notation now. What could be a descriptive word for y to relate it to cost? C. What about a change for x to represent text messages? T. Okay, very simple. So that's going to be 15 cents per text, or T, plus 20. Okay. Good. Then Caleb got his phone bill, $225. He said, what the hell, what? Okay, so figure out how many texts he sent to those that weren't on his list. So this is where you're working backwards. The total cost, C at T, was $225. That equals the rest of your equation, 0.15T plus 20. So you have to work backwards to figure out how many additional texts he sent. See how many texts Chatty Cathy sent. So it'll be 0.5t equals 225. So he sent 15 text messages. All right. He sent 15 texts, additional texts. Okay. So then we ask this question, is it discrete or continuous? Well, continuous would be cost, right? Because you can break the cost up. But what about text messages? How many of you have sent half of a text message? I don't know what that would look like. What would your phone show? Like the name? I don't know. You can't. You got to send the whole thing, right? You might not have typed it all, but it still sent the complete message. So it's discrete because it's whole text. Right? I'm sure you'd have your phone replaced. So how would you indicate that on a graph? You would just by plotting dots. Okay. No connections. So no connecting dots. Sorry, I shouldn't say dots, I should say points. Okay. Good. Now, if you send like hundreds of text messages, and you plot 100 and 200, does it make sense to have 101, 102, 103 messages? It does. So if you're plotting like hundreds, then I'd say connect the dots. Still discrete data, still discrete, but it makes sense to make a line then because there's so many messages. It makes sense to have values in between 100 and 200 or between 300 and 400. Okay? Doesn't change it being discrete though. It just means it makes sense to connect them. All right. D, what's the best way to express the domain and range? Well, because it's discrete data for the domain, you'd represent it as 0 for 0 text messages, 1 text, 2 text. We could go on and on. But I just use dot, 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 and then 14 and 15. So we showed the pattern at the beginning. Instead of writing all 15, we just used dot, dot, dot to show that it continued all the way up to 15. Make sense? A little bit of a shortcut? You okay with the dot, dot, dot? What about the range for our graph? What did we start with? Yeah, tricky, isn't it? We didn't start at 0. Dude has to pay 20 bucks if he does nothing with his phone. Then after that, what is it? $20 and 15 cents. Then $20 and 30 cents. Dot, 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 all the way up to $22 and 25 cents. So this time I just listed my final value. I'm even okay with that. Okay? It shows the pattern at the beginning, and that continues all the way up to $22.25. Thumbs up, down in the middle. Okay. Next. Shay's rate of pay has direct variation. That means there is no constant. Okay. So she gets paid, right, for what she works. Her pay works 8 hours, her pay is $92. So that's like your rise and your run. So what's your slope? What's your rate of pay? What is your rate of change? Your rate of change equals your slope. So her rise was $92. And she worked 8 hours. So you're trying to figure out her rate of change. How much does she get paid per hour? Please write the number down. Do the math, write the number down. What number did you write down? Who wrote down 11.5? Hands up. Really? Who wrote down 11.50 like they should have? Hands up. Yeah, money has 2 decimals, folks. Okay, so just because your calculator doesn't put the 0 because it doesn't need to, you should know that money needs 2 decimals. Okay, so be careful. All right, so Shay worked $11. Makes $11.50 per hour. Do you see how the slope helps find the pay? Now what you want to do is use that for 32 hours. So she gets $11.50 per 1 hour. What is that going to equal for 32 hours? So most of you know how to do this without equivalent fractions. Now use equivalent fractions. What would you do, Haley? Yeah. And if you times the bottom, you have to multiply the top as well, and that's what most of you do without even thinking. But you should know why it works. It's because you're getting equivalent fractions. And so Shay makes $368. Okay. So for 32 hours, she makes $368. Any questions? Next one. Mowat's raffle. Okay, so graph shows profit made from selling tickets. Here's profit, and here's tickets, N. Okay, so this represents tickets. This is profit. Not cost, but profit. Okay. Is the data discrete or continuous? Think about what we're plotting. Discrete or continuous? Well, they have a line. What do lines mean? Lines don't mean continuous. Lines mean nothing. Look at the data, what's being plotted. That tells you whether it's discrete or continuous. Profit, money, can be continuous. But tickets are discrete. So it's discrete because you have to sell whole tickets. You'd be in a whole bunch of trouble if you sold half a ticket. The Lottery Corporation would come down and smack you around. Okay, you have to sell a whole ticket. So why do you think the points are joined on the graph then? Yep. Yeah, because there's a large number of tickets. Okay. We're graphing like hundreds here. It makes sense to have a line because you're selling, the points are like from 200 to 300. Okay. Describe the domain and the range. What's your domain? What would be your domain? 0, 1, 2, 3, continuous. So what you can say for the domain is that it's x is greater than or equal to 0, but it has to be whole numbers. Okay. What about that's a little bit different, right? I'm kind of stipulating that we have discrete data by saying that it has to be whole numbers. What about the range? Y has to be greater than -800. Okay. Now we have, what's the cost per ticket? We haven't covered that yet. Let's figure out M. Find your slope. We need the cost per ticket. So rise over run. So here, use this point here Find your rise, find your run, please. Be careful because the squares go up by a large number. So for your rise, you go up 3 squares, which represents $1,200. For your run, you go all the way up to 400. So it's going to be $1,200 over 400 tickets. So that equals $3 per ticket. So for your range, y is greater than or equal to negative 800, and you go up by multiples of 3. Okay, and that's because each ticket you sell, you make $3 off of it. Why did we have to state this? Why did we have to state these two things? Why couldn't we just have the inequalities? Because it's discrete data. Okay? Because it's discrete data, we had to state that. Now that's pretty high end, okay? That's pretty high end. So it's a little bit weird. I think I even mark it super generous on the test. Okay. Next. Determine when P at n equals 4,000. So what does profit equal? Let's come up with our function equation. Y equals mx plus b. What's our slope? 3. What's our intercept? Where do we cross the y-axis, folks? Negative 800. How can that be? How come before we even sell a ticket, we've lost $800? That's right. For your y-intercept, that's going to be negative $800, and this is the cost to run the raffle. So you got to print your tickets, you got to buy your prizes, okay, and it costs money. So for your function notation, we'll use P at n, that equals 3n minus 800. Now you're working backwards. Okay, so substitute in $4,000 equals 3n minus 800. Work backwards. Go solve for n. What does n equal? 1,600? Yeah. So you must sell 1,600 tickets. Okay. Any questions?